Good morning, fellow students. We are welcome again to a new lesson. Recall when we started this chapter, I said we were dealing with functions, mappings, and relations. So we saw the different types of mapping, one-to-one, and so on and so forth, or relations and so forth. So now we will be working with functions. We are working with functions. And from what you see on the board here, we need to define a function. That's our new lesson for today. We're working with functions. We need to get the definition of a function. So what is a function? Get the definition. This is a kind or type of mapping in which an element from the domain is mapped to one and only one element in the codomain. Recall we did one-to-one mapping. So when one element from the domain is mapped to one and only one element in a codomain, it is called a one-to-one mapping. So that is an example of a function. Then we should be very careful with this definition, because students always get confused at this point. That's why I say you should note all functions are mappings, but not all mappings are functions. So all functions are mapping, but not all mappings are functions, in the sense that many to one mapping, one to many, and so on is not a function. It will only be a function if it is a one-to-one mapping. Okay, it is given to you. So example, one-to-one mapping. So let us look at the next thing now. The next subtopic here is notation of functions. How do we denote functions? We denote functions using 3 letters of the alphabet, and the 3 letters are G, F, and H. We have F, G, and H. Those are the 3 letters we use to denote functions. So anytime you are given a question on functions, you see us using F, G, and H. When you see that, the first thing that comes to your mind is that we are talking about functions. So in this case, I've given you the steps. You say, okay, we denote functions using the following letters: F, G, and H. So you see how it is written. F, 2 dots, is such that X is mapped to AX plus B. So in that case, this should not frighten you. We are indirectly saying that F of X is equal to AX plus B. The second one is G, such that X is mapped to MX plus Y. Indirectly, we are saying that G of X is equal to MX plus Y. And the last one is H, such that X is mapped to PX plus Q. In essence, we are saying that H of X is equal to PX plus Q. Full stop. We've seen how to denote functions. Now let us look at the types of functions. So there are different types of functions. There are so many of them, but I've enumerated a few. The first one is a polynomial function. We know this one. We did that at sharp maths, and we have been using it in maths when we did polynomials. Say ax cubed plus bx squared plus cx plus d. It's an example of a polynomial function. The next type now is a rational function. That is f of x equals ax plus b over cx plus d. So when you take a function and you divide by something, it gives what we call a rational function. And then the last one is exponential function. When you have something raised to a certain power, it is exponential. For example, I've indicated e to the x. I can also write 2 to the power y, and so on. Those are exponential functions. But in mathematics, we shall dwell much on polynomial functions and rational functions. So exponential functions and so on are meant for those who are doing additional mathematics and so on. But for maths, we dwell much on polynomial functions and rational functions. So we've seen the type of functions. Now we want to move to the domain of functions. What is the domain of a function? That's the first thing. We need to be very careful with these steps. What's the domain of a function? The domain of a function is defined depending on what? The type of function we are dealing with. So you cannot talk about the domain of a function when you don't know the type of function we are dealing with. So we define the domain based on the type of function we are dealing with. So I said if f of x is a polynomial function, polynomial means it is not divided by anything. It's just given to you in the form of a polynomial. So if f of x is a polynomial function, then the domain is always defined based on what? R is a set of real numbers. So you have, for example, f such that x is mapped to 3x plus 4. That is what I have. And this situation requires, so when you see this map, it should not confuse you. You're indirectly saying that f of x is equal to 3x plus 4. So how do you calculate the domain now? You simply let f of x to be equal to 0. That's why I say now 3x plus 4 is equal to 0. You see, and you solve for x. When you solve for x, we discover that the answer belongs to the set of real numbers. So the domain, always denoted as dom f, domain of f is x such that x is an element in R, because negative 3 on 4 belongs to a set of real numbers. So we have that situation. We have now talked about the domain of a given function. Always equate the domain, the function, if it's a polynomial function, you equate it to 0 and solve. Okay, but if it is a rational function, I've seen an example of a rational function. You take the denominator, equate it to 0 and solve, and from there we can state the domain. We are coming to that. So I'm going to give 3 activities. We work with the 3 activities. I'm going to solve for you to see, and then we look at the enjoyment that follows. All right. Now look at these activities. They say state the domain of the following functions. The first function is f such that x is mapped to 2x plus 5. The second function is g such that x is mapped to x plus 1 over x plus 2. And the third function is h such that x is mapped to 1 over x plus 5. If you look at the function script, discover that the first one is a linear function which falls under polynomial function, and the second one is in the form of a fraction, that's a rational function, and the last one is also in form of a fraction, which is a rational function. So I'm going to solve. The first one, we're saying that f of x is equal to 2x plus 5. Okay, if I have f of x to be equal to 2x plus 5, then recall I said for you to actually come out with your domain, you must equate it to 0. So here I'm going to equate my f of x to 0. So we have 2x plus 5 equals 0, implies 2x is equal to negative 5. So now look for x, right? So x will be negative 5 over 2. Alright, so my domain now, you see negative 5 over 2 belongs to a set of real numbers. My domain now will be f such that x belongs to a set of real numbers, because negative 5 over 2 is in the real numbers. It belongs to a set of real numbers. So I'll now take the second one, which is a rational function. We are told that g of x is equal to x plus 1 over x plus 2. Okay, so now to get the domain, I take the denominator. In this case, when there is a fraction used by the denominator, I take the denominator and equate it to 0. So I have x plus 2 equals 0, implies x is negative 2. Okay, so the domain is going to take every element in the set of real numbers excluding negative 2 in this case. So we take the domain, we say dom g is equal to, you have x such that, okay, x, okay, belongs to a set of real numbers excluding negative 2. Why am I excluding negative 2? This calculated value here, if I put it at the denominator, it's called a denominator, it will give negative 2 plus 2, which is 0. So anything divided by 0 is infinity. That's why I am excluding negative 2 whenever I am looking for my domain. So you always equate the denominator to 0, and then if it's a fraction, now you exclude it. Okay, if it's not a fraction, then you just define it over the set of real numbers like we did in the first case. So whenever the function is rational, that's a fractional function. Now you equate the denominator to 0, solve, and then your domain, when you are stating it, you exclude that value. But if it is a normal function like polynomial function we saw above, the domain will just simply be the set of real numbers. But you must solve and show us the steps for us to see and know what is happening. Okay, we've seen that. We've seen how to come out with the domain of the two types of function, the polynomial function and the rational function. So those are the domains of the function I've shown you. Now we have for the last function that you will do it on your own, and then we look at the enjoyment. So I have given you the functions. Now I'm going to put the enjoyment for you to go through. You copy and we solve, or maybe you solve and then you present to me the next lesson. All right, that notwithstanding, let's look at our enjoyment. Enjoyment, this is what you are going to do for me. After solving the C part, h is such that x is mapped to 1 over x plus 5. So now we want to move to the enjoyment. They say you state the domain of the following functions. The first function is f such that x is mapped to 2x plus 5 over 3x plus 2. The next, we have g such that, okay, x is mapped to 5x plus 3. And the last one is h such that x is mapped to x plus 5 over 3x plus 7. Alright, it's been nice having you guys for the class of today. I'm so impressed, and you have the lessons. Please make sure you solve and present your solution to me as required. Okay, so I'll be waiting for your enjoyment, and where you don't understand, please let me know. Send your solutions to me on WhatsApp. I mark correct and do the corrections for you to see. If you don't understand anything, let me know. I'm always available. It's been a pleasure working with you guys. Have a nice day. Thank you.